Assalamualaikum. Hi, we are from Group 1 and today we are going to present about ME Engineering Lab 1 for Lab 2. The aim of this experiment is to study how to use common hand tools and appreciate the importance of fitting work in the trade. So we will be focusing on the operations on the workbench such as sewing, filing, chiseling, and marking out. So this experiment also involves changing a workpiece by using hand tools such as files and hacksaws. By conducting this experiment, it will help new mechanical engineering students to be introduced to tools and machines used in the industry.
Good day everyone, my name is Azif Shahin Rifdi bin Rosli with my metric number MA24055 and I will be presenting on how the measurement tools and equipment help us to achieve the features dimensions in the benchwork lab, which is lab 2. And then for the first one tool is bench vise. The bench vise secures the mild steel plate while we perform operations like filing and drilling. This stability ensures we achieve dimensions such as the 102 mm length and 52 mm width without deviation. And then for the marking out table, the marking out table provides a flat surface for accurately marking lines and points on the workpiece, like the center positions for the drill holes and in the drawing, specified in the drawing. And then for the hand files are used to smooth edges and ensure the workpiece meets precise measurements, such as according to the drawing is 6 mm thickness indicated in the drawing. This ensures clean, burr-free surface. And then for center punch, the center punch we use to mark drilling points precisely, ensuring the hole positions align with the drawing specifications. This step is critical for maintaining accuracy when using the drill. And then L square. The L square helps us to mark and verify 90-degree corners, ensuring the sides of the workpiece match the rectangular shape and dimensions specified in the drawing. And then for the vernier height gauge, the vernier height gauge is used for marking vertical dimensions such as the precise height of the holes or lines to be drilled according to the drawing and ensuring they match the drawing details. And then for scriber, the scriber helps us to mark fine lines on the workpiece, helping us outline features like the positions for cuts or holes as specified in the drawing. And then for the last one is file cut. The file cut cleans metal shavings from the hand files, maintaining the effectiveness in shaping the workpiece to match the drawing's dimensions. So to conclude, by using these tools correctly, we ensure the final workpiece aligns perfectly with the given dimensions and features, like the rectangular shape, precise hole placements, and smooth edges in the drawing. Thank you. Then I will be passed on Eunice Naidu to present on the next measurement tools and equipment.
Good day everyone, I'm Yunis Naidu Govindarajalu with my matrix number MA24118 and today I'll be presenting about the measurement tools and equipment that will be used in this lab work to determine the dimensions and making the features. The first equipment that was used is hacksaw, which was used for cutting metal and other materials. And the next equipment is the angle plate, which was used as a work holding device to ensure a precise 90-degree angle. It provides a stable and accurate base for layout and inspection tasks. The next equipment is dividers, which was used for marking out circles, arcs, and transferring measurements. Dividers help in scribing lines on workpieces. The next equipment that was used was Reamer 6H7, which was used to enlarge and finish holes to precise diameter with smooth finish. And the next equipment that was used was the hand tap set M6, which was used for creating internal threads in a pre-drill hole. And lastly, which is chisel, which was used for cutting, shaping, and removing material from the workpieces. That is all from me. Thank you.
Special purpose of the equipment. The first tool is the bench vise, also known as a parallel jaw vise. It consists of a cast steel body with a mover and fixed jaws. The key features include a replaceable jaw plates, a handle, and a square threaded screw that moves the jaws via a spindle. The jaws have a width of 18 until 140 mm and a maximum opening of 95 until 180 mm, making them ideal for gripping workpiece securely during operations. The spindle adjusts the movable jaw, while the main screw applies pressure for a firm hold. Next, we have files, essential hand tools for shaping and smoothing surface. Made of high carbon steel, files features a two blade with a tang that fit into a handle. They are available in various shapes including flat, round, and triangular for different applications. For effective filling, secure the workpiece horizontally in the vise. Apply pressure only on the forward stroke. Use a straightedge to check surface flatness. Any visible line between the straightedge and workpiece indicate unevenness. Next, the hacksaw. The hacksaw is a versatile cutting tool with a U-shaped or C-shaped adjustable frame. It holds a carbon steel, bimetal, or high-speed steel blade that under tension. Blades are typically 0.7 mm thick and 20 to 30 cm long. They come in cost 5 to 7 teeth per centimeter and 8 to 12 teeth per centimeter tooth group for different cutting needs. The features include a pistol grip handle for comfort, a tensioner for blade tightness, adjustable setting for scraping wider or more precise cut slope. For tri-square, the tri-square is used for checking right angle. It consists of a hardened steel blade fixed to a rectangular steel top. The inner and outer surface ensure precise 90-degree angles. It ideal It is ideal for verifying in surfaces are straight, flat, and square relative to each other. Scriber. The scriber is a handy marking tool. It's a slender, pointed steel tool measuring 150 to 300 mm in length and 3 to 5 mm in diameter. It has one straight sharp end and a bent sharp end for making hard to reach area. It creates shallow scratches on surface, acting as a guide for cutting or measuring. The vernier height gauge is a precision tool for measuring vertical distance, part height, and hole depth. It provides accurate marking of straight lines on workpiece, ensuring greater precision than a ruler. This tool is ideal for layout work, ensuring exactness in measuring processes. Last but not least, the vernier caliper. The vernier caliper is a highly versatile measuring tool used in fitting, machining, and quality control. It measures length, width, height, depth, and the inner and outer diameters of objects with a typical precision of 0.02 mm. It's indispensable for tests requiring precise measurement of external and internal dimensions or depth.
Now, I will talk about lab work. As you can see in the first slide of the lab work is the equipment that we use in the first week of the lab 2, and we put the workpiece on the bench vise, as you can see in the second picture. And after that, for the third picture, we filing the workpiece down to the fourth slide. We create a straight line using the vernier high gauge for easier cutting with the hacksaw. So in this picture, as we can see, we are assisted by Mrs. Nur Saadah. And then after marking with vernier high gauge, we put the workpiece back on the bench vise for sewing and a bit more of filing. And now for the second slide is the sixth slide. So using the hacksaw, we cut the workpiece according to the instruction given, which is 70 millimeters. And then the second picture is after we got the 70 millimeters, we used the tri-square on the workpiece again to get 90 degrees, and we use vernier high gauge to measure 100 millimeter. And as you can see for the last picture, for the first phase, we use the hacksaw again. We cut the workpiece into the 100 millimeter, and as you can see from at the picture below, you can see the result of the workpiece in the first week of the lab 2. So after that, in the first picture, we drew the workpiece using the drilling machine to create 2 perfect circles according to the instruction. As you can see, the second picture is the close-up of the drilling machine that worked upon our workpiece to create the 2 perfect circles. And after that, for the first hole, we did tapping, like you can see in the third picture. And the fourth picture, which is the last process, is that we made 10 millimeter curve by cutting with a hacksaw and following by filling on the workpiece. Finally, this is the final look of our workpiece.
My name is Muhammad Afizi Kiri bin Fazli and my metric number is MA24071. The discussion for the lab 2, which is bench work, the lab experiments provided a practical framework for understanding fundamental machining operations and the usage of basic engineering tools. The result demonstrate the critical role of precision and accuracy in achieving desired outcomes in engineering process. Through the use of hand tools such as hacksaw, files and scribers, and precision instruments like vernier caliper and head gauge, the labs emphasize the importance of proper tool selection and application for specific tasks. The dimensions and tolerance achieved during the machining and fitting process reflect the learner's growing proficiency in handling tools and understanding material behavior. Despite some minor inconsistencies in precision, which were largely attributed to manual operations and skill development, the overall objectives were met. This variance highlighted the challenges of achieving consistent results in manual machining, reinforcing the need for patience, practice and careful planning in engineering workflows. One significant takeaway is the value of proper measurement techniques. The precision afforded by the vernier caliper and head gauge not only ensured the adherence to design specification but also minimized errors in subsequent assembly operations. Additionally, the integration of making and measuring with cutting and drilling process showcase the interconnected nature of mechanical tasks, where the accuracy of one step influences the success of the next. The implication of these findings extend to both academic and professional engineering practice. The foundational skills honed in the lab provide a solid basis for more advanced machining tasks and contribute to a better understanding of quality control principles. Furthermore, the emphasis on safety and procedural discipline underscore their necessity in minimizing risks and ensuring operational efficiency.
Okay, so in a nutshell, this laboratory session really improved our comprehension of basic hand tools, including how to use them safely and efficiently. So other than that, we also acquired great hands-on experience using tools such as marking, cutting, filing, and drilling, which help us build important abilities for future engineering projects. So by combining theory and practice, we can develop our problem-solving skills and acquire confidence in our ability to address engineering difficulties with accuracy and efficiency. Thank you. That's all from our group. Thank you.